If you are preparing for interviews and you've already worked on Python logic or SQL interview questions, you are on the right track. But there is one layer that decides whether your correct code is seen as beginner code or professional code. That's OOPS. This is my first video on OOPS for interview preparation, and over the next few days, you'll find a complete series here that breaks OOPS in a very simple, interview-focused way. And OOPS connects everything together, the way real projects work. Links to my Python and SQL interview playlists are in the description. They go perfectly with this OOPS series. Python helps you think logically. SQL helps you think in data. In this video, we'll start from the fundamentals, how interviewers evaluate freshers using OOPS. And in the upcoming videos, we'll go deeper into the questions that actually reject candidates. So without wasting much time, let's jump into this video.
So you're trying to break into software development, right? And you keep seeing this acronym everywhere. OOP, Object-Oriented Programming. It's plastered on every job description. But what is it, really? And why is understanding it the key that unlocks the door from being a student to becoming a professional developer? Well, we're about to find out. Okay, but let's be real for a second. Is it really that crucial? It's a fair question, one you see all over developer forums. I mean, you've probably gone through the theory. Maybe you've written a few simple programs. So why are hiring managers so, obsessed with it?
This whole feeling is perfectly captured by a user I saw on Stack Exchange. Get this. They were interviewing for a job using C, which isn't even really an OOP language, and still, half the interview was about object-oriented programming. So what gives? What is going on here? Why is this one concept so fundamental?
All right, to really get why it's so important, we've got to peel back the layers, go beyond those dry textbook definitions. We need to get to the core ideas that make OOP so incredibly powerful. They're often called the 4 pillars, and we're going to decode them one by one.
Okay, first up, encapsulation. Now, the easiest way to think about this is like a protective wrapper. See, instead of having your data just kind of floating around in one corner of your code and the functions that work on that data way over in another, encapsulation bundles them all together into one single neat package. We call that a class.
And yeah, that image of a capsule, it's the perfect metaphor. What encapsulation does is it hides all the internal stuff, the data, and it basically puts up a shield, protecting it from being messed with from the outside. The only way you can interact with that data is through these specific, approved methods that the class provides. This is huge because it stops accidental changes and keeps your code super organized and way more secure.
All right, next up is abstraction. So if encapsulation is about bundling things up, abstraction is all about simplifying. The whole point is to hide all the messy complexity. Think about it like this. When you drive a car, you just use the steering wheel, the gas pedal, the brakes, right? You don't need to be a mechanic and understand the entire combustion cycle happening inside the engine. That's abstraction in the real world.
And that's exactly how it works in code. You interact with an object through its nice, simple public methods. Those are your steering wheel and pedals. And all the messy, super complicated internal logic and data, it's all hidden away. This makes your code so much cleaner and way, way easier to work with. Okay, pillar number 3, inheritance. This one is a total game changer, and it's all about reusing your code. Instead of writing the same stuff over and over and over again, you can create a general base class. Think of it like a template. And then you can create more specific child classes that just inherit all its properties and methods. And the best part? They can add their own unique features on top. This brings us to the classic is-a relationship. A car is a vehicle. See how that works? It gets all the general vehicle stuff for free, like having wheels or an engine. But then the car class can add its own specific things, like, say, a method to roll down the windows. It's just a really smart, logical way to build things. And that brings us to our final pillar, polymorphism. It's a fancy word, but it literally just means many forms. And the magic of polymorphism is that you can use a single action for a bunch of different objects, and each one will respond in its own special way. It's like you could tell a bunch of different animals to make a sound. The dog will bark, the cat will meow, the duck will quack. Same command, totally different result. And get this, polymorphism isn't just one thing. It can happen statically, which basically means the computer figures it all out before the program even runs when you're compiling it. Or, and this is where it gets really powerful, it can happen dynamically, meaning it's figured out on the fly while the program is running. This dynamic approach gives your code incredible flexibility to make decisions as things change. Okay, that's a lot of theory, I know.
And it's all good stuff, but to really see the power of OOP, you have to see how all these pieces fit together in an actual real-world example. So let's get practical. Let's make this real. We're going to model a simple banking system because this is where OOP really shines. It lets us represent complicated, real-world concepts like a bank in a really elegant way inside our code. So here's how we think about it. First, we need a blueprint, right? An account base. This is just the abstract idea of what every bank account needs. Then, using inheritance, we can create more specific types. We've got an adult account, which inherits from our blueprint. We've got a student account that does the same. But see, each one has its own special rules. Maybe the student account has a deposit limit. And then we have a bank class that acts like a manager or a factory, creating and keeping track of all these different account objects. And now watch how this all clicks together. Okay, so both the adult account and the student account have a deposit method. They both inherited that ability from the account base blueprint. But here's the cool part. When you call deposit on a student account, it first checks for that deposit limit. When you call it on the adult account, it just deposits the money. It's the same method name, but it does two different things depending on the object. And boom, that's polymorphism right there in action in our code. Okay, so understanding those 4 pillars, that's step 1. That's the foundation. But the pros, they take it to the next level. They don't just use the features of OOP, they follow a whole philosophy for designing software. And that philosophy is called SOLID. SOLID is actually an acronym for 5 core design principles that are like a professional developer's North Star. The whole point of SOLID is to create code that doesn't break easily and is simple to add new features to down the road. For example, the S, single responsibility principle, just means every class or module should have one and only one job. The O, open/closed principle, is a fancy way of saying you should be able to add new stuff without having to change the old existing code. Following these ideas is really what separates a student project from a professional, bulletproof system. So all of this brings us right back to where we started. Why do companies care so much about this stuff? I promise you, it's not about them wanting you to recite definitions in an interview. It's about whether you understand how to solve the single biggest problem in all of software engineering. And what is that problem? It's this: handling complexity. I mean, modern software is just mind-bogglingly complex. Sure, if you're building a tiny little app, you can get by with simple functions. But when that program grows to thousands or even millions of lines of code, you absolutely need a strategy to manage that chaos. Without a solid structure, the whole thing just becomes a tangled mess that's impossible to understand, let alone maintain. And that is why object-oriented programming became the king of the hill. When you compare it to older ways of programming, it just offers so much more. You get better data security because of encapsulation, you get massive code reuse from inheritance, and you get a way of thinking about problems that just scales so much better. It gives huge teams of developers a common language and a stable framework, so they can actually work together to build these enormous complex systems. And this quote from that same forum thread we saw earlier just nails it. See, as a student, you're usually working on small projects. They're done in a couple of weeks. And in that world, yeah, OOP can feel like way too much work, like overkill. But in the professional world, where a single code base might live for a decade and be touched by hundreds of different developers, in that world, OOP is not a luxury. It is absolutely essential. It's the very thing that keeps those massive projects from just collapsing under their own weight. So let me leave you with this final thought. The next time you're in an interview and they ask you about, say, polymorphism, remember what they're really asking. They're not just checking if you memorized a definition from a textbook. They're trying to figure out if you have the mindset to build software that's meant to last. Because at the end of the day, OOP isn't just a bunch of features in a programming language. It's a fundamental way of thinking. It's a blueprint for designing solutions that can grow, that can adapt, and that can truly stand the test of time.
If this video helped you understand how OOPS is judged in interviews, this is just the beginning. In the next videos of this series, we'll break down core OOPS concepts with real interview questions and common mistakes freshers make. If you're serious about cracking interviews, watch the TTG channel regularly. Like this video, share it with friends who are preparing, subscribe to the channel, and check the Python and SQL playlists linked in the description.